Hello viewers and my dear students. Welcome to session 2 on problem 7 on analysis of beams. I'll be giving you a demo on simply supported beam analysis with T-section and transverse pointed loads on the flange using Ansys Mechanical APDL to obtain bending stress and deformation diagrams. As you know, this is session 2. In session 1, I concentrated on the same T-section. I concentrated only on reaction solution, shear force diagram and bending moment diagram. Here I'll be concentrating on bending stress diagram and the stress developed at the top fiber, bottom fiber and all that. Okay. Now this is the problem what I've already told you. This is the beam of span 4 meters and this is the any section here. So far we are getting rectangular section and all that. No? Here it is a T section. This is flange, this is web, 120, 10, 150 and all that. There are two pointed loads, 15 kilonewtons, 20 kilonewtons and all that. When so much load is applied, what is the binding stress developed at the top fiber and the bottom fiber, that is here and here, to be determined. That's what we'll concentrate totally on, that is finding maximum bending stress using theoretical method and as well as using Ansys. Okay, now you see here these things, that is this is the T section, 120 by 10, 150 by 10 and all that, finding the center of gravity, finding moment of inertia and all that. It is left to the reader as an exercise. Please go through that. This anyway we will get it directly in Ansys in this section, in the beam section and all that. Okay, now you see here bending moment diagram calculation. This also we have already done. See here, bending moment at D and supports it's 0 and bending moment at C is 2.25 into 10 to the power of 7 Newton millimeter and bending moment at B is 2.5 into 10 to the power of 7. That means here you have maximum bending moment, that is 2.5 into 10 to the power of 7 Newton meter. This is 2.25 into 10 to the power of 7. Okay, this anyway we'll prove it using Ansys. Okay, now I see here, this is another important thing. Again we'll prove it in Ansys. Maximum bending stress at the top fiber is, you give M into Y by I, no, top fiber 49.44. M maximum bending moment is 2.5 into 10 to the power of 7. This you substitute, you get this at the top fiber. Bottom fiber 160 minus 49.44 you do. See, substitute the same thing. You are getting this 389. This 389 and 174. Top fiber 174, bottom fiber 389. Anyway, we are going to prove in Ansys. Okay. And bending stress diagram also, as you know here, this is 389. This is for the bottom fiber only, 389. And in this place, if I put 2.25 into 10 to the power of 7, you get 351 MPa. This also we will verify it in Ansys. Now we will go directly for Ansys. Okay, Ansys will go. We have created a new log file, Gurudat T section bending stress diagram, and I have created a title also. Now we will go in the same way. Preferences, structural, okay you do, preprocessor, element type, add, edit, delete, add, beam 2 node 188 only you take. Okay. Then just say close. Then material properties you take, material models, structural, linear, elastic, isotropic, you take 2.1 E5 you take. Okay. This is 0.27 Poisson's ratio you take. This 2.1 into 10 to the power 5 Newton per millimeter square. That means the loading should be in Newton and the modeling should be in millimeter. That is why I have taken 2.1 E5. Okay, Newton per millimeter square. Okay, this you do. Okay, material, etc. Then section you have to go. Beam common section you go. Then here, as you know, you are so far taking rectangular section. Now you will take I section. I section, sorry, T section you will take. T section you take. This is 120, you know. 120 you take. This is 160 you take. Okay, 150 plus 10. Okay, from here it is W2. W2 is 160. T1, T2, 10 and 10. Okay, 10 and 10 you take. Then all you get, if you go for preview, okay, if you go for preview, whatever I got now, that theoretical method, IYY, 0.709 into 10 to the power of 7 and all that, whatever you done, all you get it. Okay. Anything, even center of gravity also you get it. Okay. Now what you do, next modeling you go, create key points. In active coordinate system you go 1, 0, 0, 0 you take, apply. Okay, 1, 0, 0, 0. 2 you take, 2 is 2000, 0, 0, 0, you apply, you do. Then 3 you take, 3000, 0, 0, you take, that is 3. Then 4 you take, 4000, 0, 0, you take 4. And this is important point, 5 you take, that is the orientation point, 4 minus 1000. To change, that is to rotate the beam by 90 degrees, this is very important, I tell you. This 5 also you take. Okay, once you get this, then create lines, straight line, join this to this, this to this, this to this. Okay, just say okay. Then you go for meshing, mesh attributes, picked lines, pick all the 3 lines, and very importantly, you see here, this pick orientation key point, compulsorily click on this, OK, and click on this 5. Then only it will rotate by 90 degree. Then you say OK. Okay, now once you do this, size controls you go, manual size, lines, picked lines, you pick all the 3 lines, just say OK, and you say maybe 20 divisions here. That is number of element divisions, 20 you take. Okay, just say OK. That means mesh lines, pick all if you do, you will have 60 elements got. Okay, list elements if you do, okay, 60 elements you would have got. Now whatever we have done till now is okay. Okay, now once you do this, you just check whether that orientation is proper or not. Size and shape, okay. Display element, okay. Then you just see here, you see here, the orientation is proper now. Okay, orientation is proper. It is, you are loading on the flange, not on the web. This is web, this is flange, or we are loading on the flange. Okay, in that way, I'll go to the front tube. I'll fit it. That means your orientation is proper. Your answers will also be proper. Style, size and shape. I'll take this display element off. Okay, I'll just load now. Loading, I'll go. Loads, define loads. Apply, structural, displacement on key points. You click on the first and the last point. It is simply supported. Okay. UX, UY, UZ. Rotation X, rotation Y, you make it 0. Okay. Once you do that, then force moment you take on key points on the first key point here. Okay. First loading point. Just say okay. Fy you give, and it is minus 15,000 as you know. Minus 15,000. It is applied here. And on the next key point, it is minus 20,000. Minus 20,000 you do. This is also, see here, now everything is okay. Now as you know, this orientation is proper and the loading is also proper. In that way, now what do you do? Solution, solve, current LS you do, just say okay. Wait for that output message. The solution is done, Okay, now you have done correctly till now. See here, this is correct till now. Now once you do that, that means pre-processing phase is over, solution phase is over. Now we will go for post-processing phase. That is why general post-process you go. First thing what you do is whether you have done correctly or not, list results you go, reaction solution you check. If that is correct, every other thing will be correct. Then you see here, node 1, it is 12,500. Node 82 at the last, it is 22,500. Just I have already told you, these are all the reaction solutions, what you should get. with reference to this only we have done everything. Okay, that means the reaction solution is proper now. Now once you do the reaction solution properly, okay, then what you do is element table you go, define table you go, add you do, by sequence number 34 you take, apply. This is by sequence number 39 you go and you say apply or okay. Okay, that means okay, 34 and 39 will give us the bending stress diagram. Okay, 34, this item and sequence number, this is item, this is sequence number, this will give bending stress diagram. Okay, just say close. Okay, now you see here what you have to do is, now if you go for plot controls, style, size and shape, display element on, you just say okay. You see here, okay, if I do plot, multi-plot, if you see here, symbols, all applied boundary conditions, no? Okay, you see here, perfectly it has been done. Can you understand? It is applied on the load is applied on the flange. In that way, it is all proper. Okay, it is all proper. Okay, now what you do, once everything is proper here, now what you do, plot results you go, deform shape you go, deform plus undeformed you go. In that way, you see here beautifully the load is applied, and exactly if I take the front view of this, it is 26.05 mm. So much is the deformation. The load is huge. In that way, the deformation is so much here. Okay, and 26.0566 mm is the thing. And this you please record it. This is one of the very important things. In the same way, if you take line element result contour plot, nodal solution, okay, x component of stress you take. X component of stress, be careful to find the stresses developed in the top and bottom fiber. See here, this we have already proved. The stress developed at the top fiber is, you see here, blue, minus this is compressive in nature, this is tensile in nature. Okay, this is compressive, bottom is tensile. That is, at the bottom it is 388.9 Newton per millimeter square or MPa. It's a huge load. It is almost at the breaking level. Okay, this is 388.9. What you had got is 389.9. Okay, it is almost correct. At the top it is 174. It is 173.83. In that way, it is more or less we have done everything properly. This is another very important thing. Never forget, this is another very important plot. What you have to record it and show it to the examiner. Then line element result you go, and 34 and 39 you see. Just say okay. Once you do this, this you see here. This is another very important thing. Bending moment, bending stress diagram. See here at the level here, 388.9. Okay, actually 389. 389 we got. Here 389. In the red zone you see. Red zone variation is 388.9 to 346.664. That means here it is 388.9. Actually we have got 389. That means it's almost perfect. Okay, and at this stage it was 351 what we had got. Now it is 346.664. That means this is another very important thing. What has to be recorded? Okay, what has to be recorded? And in the plot controls and this write meta files, invert white and black. In that way, this also has to be shown to the examiner. Write it in the records and all that. Please be careful here. I've shown you some important things here. Deformed shape, deformed plus undeformed I have shown. This is very important. This also you show it. Okay. And contour plot, nodal solution also. X component of stress. This also you show it. Okay. Even in isometric view also. This also you show it. This is another very important thing. What has to be shown to the examiner or write it in the record and all that. In that way, we have completed this very crucial T-section problem, how to find bending stress and deformation diagrams and bending stress plot and all that I've shown you. Thank you, friends. Thank you very much for watching. Thank you.